Good afternoon, everybody. Or at least it's afternoon here. Um, this is the last of the topic 2 lessons that we're doing, and it is the last of the properties in this series. Now, there will be more mathematical properties that you use or learn, but this is the last one for quite a while. This one, the distributive property, this is just a preview into it. It becomes a fantastic tool for solving equations. But at this point, we're just kind of showing you how it works and how the things are equivalent. And later in the spring, when we get into solving bigger equations, you'll really see where it might become a tool that could help you. Okay. So if you notice in this example, 3 times the quantity 5 plus 7 is equal to 3 times 12. Well, 5 plus 7 is 12, so I'm going to believe that, yep, they're both 36, okay? And 3 times the quantity 5 plus 7 is equal to 3 times 5, 15, plus 3 times 7, 21, okay? Here is the biggest deal, and I know equations aren't our topic right now, but we've been spending all our time so far in expressions. And I've been saying an expression doesn't have an equal sign. Expression doesn't have an equal sign. Okay. Here we have an equal sign. The purpose of an equal sign is never, its job is not to point out an answer. Its job is to show that both things on either side are equal. Okay. It's showing that you have a balanced sentence. So if this equation is true, which it is, then you can put an equal sign and say, yep, those values are the same. Why are they the same? Because of the distributive property. Okay, so the property, again, is just a law pointing out something that you could show. You knew mathematically that those were true. Okay. So at this point, when we see it written like this, it can feel very silly. Like, why would I ever do that? You're right. This is kind of training wheels. But if we don't learn with real numbers, it becomes almost impossible to learn in algebra with variables. So we're going to start it with training wheels. That's okay. Now, notice you can also remove a common factor. Okay, and we had a little preview lesson on factors, the pieces that make up a product that is a number, to write something or solve it differently. Okay, so 50 minus 15. Well, is it the same as 5 times 10, that's 50, minus 5 times 3, that's 15? Well, what if I take out that common factor, in this case 5, and I say it's the same as 5 times 10 minus 3, 5 times 7, which is 35. Do they all equal 35? And if you went through and looked, you would say, yeah, they do. Okay, so again, I know it feels silly at first, but please, we'll keep working with this and you'll see. So an example of something you might do for a homework problem would be to use the distributive property to rewrite an expression. Okay, now this is where one of my son's favorite teachers, I think in middle school, referred to this as the boing boing property. Now I'm going to show you it because it helps you not mess up. I'm going to rewrite the problem. 4 times the quantity x plus 3. Now remember that whenever you have a number in front of a parentheses like this, kind of in a coefficient status, it is being invisibly multiplied. But there's more than one thing inside the parentheses. Yes. You are multiplying times that thing and times that thing. Okay? Boing, boing. So look what happens. It's actually 4 times x plus 4 times 3. We are distributing that 4. Okay, and this is an old reference, but it's meme-worthy old reference. Okay, it's like Oprah standing on a stage and you get a 4, you get a 4, you get a 4. Everyone gets 1 distributed. Okay, in real life, life's not fair, but in math, yeah. Now, this is okay mathematically, but it's not finished. I don't need these parentheses. 4 times x is just 4x plus 4 times 3 is 12. So the distributive property could be used to rewrite an expression to its equal value in a different format. We can also reverse this. Okay, and this is a little bit advanced, but nothing you can't handle. Okay, so we're going to use the idea that we did earlier this week of what a factor is, and I'm going to demonstrate it. We will practice it in class as well. So I'm looking for a common factor between these two. What is something they'd be commonly divisible by? Well, for sure 9. So this is 9 times 3 times y. So 27 is actually 9 times 3. Minus 9 times 2. 18 is 9 times 2. Okay? I didn't do anything different. I just rewrote it in a kind of an expanded form. That's what factoring does. It expands it into its pieces. Well, look what's in common here. So now I can do something called factoring out. All it means is I only have to write it one time. So I'm going to write the 9 down and a parenthesis, because 9 is now times everything inside. 3y, because that was left. Add a little color here for you. Minus 2, because this 2 was left. And if you notice, distributing and factoring are just inverse operations. They are the opposite activities of one another. Okay? Now, after this video, I want you to go and read through some of the examples in the book. I also want you to go and do the try problems. We're going to do this in class as well. Okay, this is not your only lesson on this, and it's something we will continue to work on through the spring. Okay, very proud of you. Have a wonderful evening.